The optic system performs two functions: excitation and collection. During excitation, laser beams are directed towards the flow cell for interrogation of the sample core. Excitation components include the lasers, beam-shaping prisms, and lenses to route the laser beams to the flow cell. Collection involves the gathering of scattered and emitted light from the sample and the routing of collected light to the appropriate detectors. Collection components include lenses that collect the scattered and emitted light. Fiber optic cables direct the emitted light to the appropriate detector arrays. Filters and mirrors transmit specific wavelengths of light to each detector. In the BD Fax Canto 2 422 flow cytometer, 3 lasers are used to interrogate the sample. Excitation components include the fiber optic cables, prisms, and lenses that guide the laser beams to the sample stream. See how the excitation components work to guide the laser beams to the sample stream for interrogation. Collection components include the forward scatter diode, collection lenses, fiber optic cables, and detector arrays. As cells or particles pass through each laser beam, the resulting fluorescent and scattered light signals are routed to laser-specific arrays of detectors. The BD Fax caliber system includes a blue and an optional red laser. The lasers and the lens that brings the lasers to the flow cell form the excitation system. The collection components consist of lenses and filters that bring the light to the detectors. Excitation optics center the laser beams onto the sample core for interrogation. The intersection between the lasers and the sample core must be stable to collect accurate data. In cytometers such as the BD Fax Aria, the BD Fax Canto, and the BD Fax Caliber, the lasers are held in fixed positions and interrogation occurs in the cuvette flow cell. The BD Influx Cell Sorter features stream and air interrogation that must be aligned daily to obtain optimized signals. BD Fax Canto 2 cytometers consist of fixed lasers. BD LSR cytometers consist of fixed lasers. In BD influx cytometers, stream and air interrogation requires daily alignment by the operator. Individual laser positioners allow for fast and intuitive independent laser beam alignment. LASER is an acronym for Light Amplification by Stimulated Emission of Radiation. Lasers generate intense beams of coherent light. In flow cytometers, lasers serve as the excitation light source for sample interrogation. Additional laser options are available for some cytometers through the BD Special Order Program. The collection components steer the scattered and fluorescent light to appropriate detectors. Scattered and emitted fluorescent light are collected by appropriately positioned lenses. The lenses focus fluorescent light emitted at each of the laser interrogation points onto fiber optic cables. Fiber optic cables then route the light to a set of filters and detectors. Collected light is routed to specific optical detectors in octagon or trigon-shaped arrays that maximize signal detection from each laser. Light signals resulting from blue laser interrogation are routed to detectors in an octagon array. In front of each detector are filters that reflect and transmit specific wavelengths of light. The filters ensure that the highest wavelengths are transmitted to the first photomultiplier tube, PMT, while lower wavelengths are reflected to the next PMT in ascending order of energy level. Visible light consists of wavelengths ranging between 400 and 700 nanometers. Wavelengths correspond to different colors. Optical filters are used to direct specific light wavelengths or colors to each photodetector. Click each filter type to view its effect on light. Long-pass filters transmit light that is equal to or longer than the specified wavelength. Bandpass filters transmit light around the first value within the range specified by the second value. Bandpass filters transmit light around the first value within the range specified by the second value. Short-pass filters transmit light that is equal to or shorter than the specified wavelength. Short-pass filters transmit light that is equal to or shorter than the specified wavelength. Reflect on what you have learned in this module. What are the main functions of the optic system? What is the role of lasers in cytometers? How are longpass, bandpass, and shortpass filters used to route specific wavelengths Reflect on what you have learned in this module. What are the main functions of the optic system? What is the role of lasers in BD cytometers? How are longpass, bandpass, and shortpass filters used to route specific wavelengths of light to the appropriate detectors? Click Next to take a quiz and check your understanding of the content shown in this module. Now that you have completed this module, you should be able to